Welcome to Algebra 2. This is section 1.0, even though at the top it says 1.1. 1.0, this is just an intro lesson, really review heavy. This whole chapter 1, is just going to be very review heavy because for most of us, it's been a while since we've taken Algebra 1. So I'm just getting a little bit of prep before diving into Algebra 2 concepts. So I'm going to note that initially we're talking about linear equations, and there are three main forms for linear equations that we use: slope-intercept, standard, and point slope. Of these three, without a doubt, one that we use the most and probably remember the most is slope-intercept. We remember y equals mx plus b even if we do not remember the name. With y equals mx plus b, it's important to note that m is the slope and b is the y-intercept. The other forms are also useful at different times, and we'll talk more about those throughout the chapter. Here's just kind of an outline for the chapter and what's going to come up after this lesson. So, are you ready? Okay, so what is a line? What does it look like? So some different things we know about a line. We know that it's infinitely long. We also know that it doesn't curve, aka it's straight. We know that it's drawn with arrows on each end to show that it goes on forever. And one thing, I'll just draw a quick line in here, you don't have to draw this in yours, I recommend not, is that if I draw a line like that, and I draw another one like this, you can't actually just say that, hey, one of those is thicker or thinner, even though they look that way, they were just drawn differently. But really, lines have no width or height to them at all. So before I go on to the intercepts, I'm going to talk about this parent function. So parent function just means a basic function with no changes to it at all. So f of x equals x, aka y equals x. Remember that y and f of x are interchangeable. So that would start at the origin and have a slope of 1. And just look like that. It's an x-intercept. It's where it crosses the x-axis. So in this case, it crosses the x-axis right there at the origin. So where the graph line in this case crosses the x-axis. The y-intercept, same idea, just with the y-axis. So where the graph crosses the y-axis, which is the one that goes up and down vertically. So it's this axis, and it intersects it, hey, right there at the origin as well. Now I want to note that with both intercepts, starting with the x-intercept, if it's going to cross this line, it can't be up here. It also couldn't be down here, or here, or up here, or anything like that. It couldn't even be right there. It couldn't be there. It has to be right on that line. And I make this point so aggressively to emphasize that the y value, aka the up and down, for when it crosses that line, the x-intercept has to be 0. And the same can be said for the y-intercept. That's not crossing the y-axis, nor there, there, or even that close. That one is, though, because the x value, the left and right, is actually 0. So what is slope? Okay. Well, we might think of things with slope like rise over run, or, you know, up and over, or things like that. I think one of the best ways for us to think as far as a definition of slope, or kind of more of a more usable definition, is the rate of change. It is the rate of change. So whether that's talking about just specifically how we see it on the graph, or just let me see how I in a table, that'll always be the slope. And a reminder that we use the variable m to be slope. So how do you calculate slope? Well, let's say we don't have a graph by any means, so we can't just count how far up and over it goes. You would use the formula. M equals y2 minus y1 over x2 minus x1. Now, specifically, the y's have to be on top and the x's have to be on bottom. You do not have to have y2 first on the top. You could have y1 first. However, if you have y1 minus y2 on the bottom, you could not do x2 minus x1. You would have to line them up vertically and say, hey, x1 and y1 have to be both first or both second, meaning both x2 and y2 would have to be second there. I'll talk more in depth on that once we get to some slope examples. Oftentimes, like I said, we will think about it as rise over run, how much it changes up and down versus how much it changes left to right. So why are they important? And not just because your math teacher says so. So they help us compare how two variables interact with each other. So we can see, hey, as one variable gets higher or lower, increases, decreases, what happens to the other variable? Does it have any effect? If so, what kind of effect, and those things. So what are some linear relationships we see in everyday life? If you're watching this video, you might not have a partner next to you to discuss this with. So maybe the amount of time that you're walking or driving compared to how far you go. So maybe I'll just put time and distance. You might say, hey, I have 30 minutes to drive. Can I go this distance? Do I have time to run home and back real quick before whatever event? Maybe you're thinking working. You make more money if you work more hours, and you make less money if you make less hours. So those would be a couple examples, and there's so incredibly many. So ACT checkpoint, a lot of juniors take Algebra 2, and junior is a big testing for the ACT in Nebraska. So 60 questions on the math ACT, at least 2, and so it could be more, will consist of something with linear equations, functions, or relationship word problems. So here's an example of one of those. Which of the following equations represents a linear relationship between time, t, and velocity v, shown in the table below? So as I'm going through these, I want to kind of start narrowing down options. So if you remember, linear relationships, we can think of y equals mx plus b, and these are all written in that format. Just think of y as v and t as the x. So if we think of it that way, that might help us here, knowing that, hey, they do all have v equals, let me change color there, mt plus b. They're all in that format. So as we look at that, we want to say, okay, well, the two things we want to focus on to know what equation would be correct are the m and the b, because they all have v and t in there. So one way we can know slope is we said it's the rate of change. So what is the difference between 120 and 152? Well, they're increasing by 32. for 1 increase in time. As time increases one more time from 1 to 2, it increases from 152 to 184, so by 32 in the velocity. So it appears to be a consistent or constant rate of change, aka slope. So we know the m is 32. That already eliminates C, D, and E because they have 120 as the slope. So now comes the question of, well, is it going to be B or A, aka what is the y-intercept? What is a plus B? So if we recall, a y-intercept, the B, is where x has to be 0. So if we're thinking of x as t, when t is 0, v, aka the y, is 120, meaning it has to be B, because that has to be the 120. Now let's say you don't think it through this way, or you're not familiar enough with it at the time of taking this question, or completing this question. You could totally guess and check with this one. Start plugging things in. Plug in 0 for t into these equations, and you would notice instantly that, hey, you know what? The only one that actually works if I do that, or the only two that actually work if I do that, are B and E as an elephant. And from there, if you plug in 1, only B out of those two would work. Or if you plug in 2, only B out of those two would work. So that's a way you can help you with that. So now we're going to do a little bit of geometry review before hopping into some more algebra stuff. So we have this point A on the that we're going to graph, negative 2, 3. So 2 to the left, 3 up, A. And we're supposed to find the location of an A prime, aka something that's been changed to A, causes this to happen. And we can use a graph if we need to. So the first thing is translating 1 unit left. That's just moving it, aka picking it up and putting it down somewhere. So, for example here, that would be negative 3, 3. So it would be right here. So that's 1 unit left. So it's not changing the up and down. It's not changing the y value. And if we recall, it's x, y. It's only changing the x value by moving it left. So that's subtracting because it's getting lower. Now reflecting across the x-axis. The x-axis is this one, meaning if it's going to reflect across it, it's not going over here, it's going down here. So you can say, how far is it from this axis? It's 1, 2, 3 away, so it'll be 1, 2, 3 away down here. And it's not moving left or right at all. It's as if it's just being mirrored over there. So as we figure out the coordinate for this, we say, oh, that's 2 to the left, so negative 2, and 3 down, negative 2, negative 3. So this can be confusing to some of us or catch some of us off guard, because what happened is, from the original point, the x value stayed the same, even though we reflected over the x-axis, and the y value is what changed. So the y value just changed signs. That's all that will always happen when you reflect over the x-axis. So similarly, when we reflect over the y-axis for letter C, from their original point, we're going to say, hey, we are 2 away. We're going to be 2 away over here. And it's going to change the x value to positive 2, and we're going to have the positive 3 we originally did. Last but not least, translate 6 units down. So that's only affecting the y value, not the x value. So you either think of counting 6 down and finding that point, or take the original y value of 3 and subtract 6 to get negative 3. And our x value just stays the same at negative 2. So it ends up actually being the same as reflecting across the x-axis in this instance. All right. Example 2, naming x-intercepts and y-intercepts. So remember from a moment ago, we said, hey, x-intercepts have to be where the y value is 0. Y-intercepts have to be where the x value is 0. So we're going to use those facts to our advantage. So in order to find the x-intercept, we said y has to be 0. So let's make y 0 and just rewrite the rest of the equation. Doing that leaves me with an equation that we can solve. So from there, I'm going to add 4 to get 4 equals 8x. So I added 4 to both sides of the equation. And then if I divide both sides by 8, I get x equals 1/2. So that tells me the x-intercept is at 1/2. But it has to be a point, so what's the y value? Well, it's the 0 we were talking about, because we said the y value has to be 0 when it crosses the x-axis. As we do the y-intercept, we have that same original equation, but I'm going to make the x value 0 and solve that. So 8 times 0 is 0, and 0 minus 4 is just -4. So this ordered pair, the y value is -4, and the x value, since it's the y-intercept, is 0. For those of us that are more visual learners, seeing this graph up here might help. So I'm just going to use this graph up here since it's conveniently there. And I'm going to graph those 2 points at 1/2, 0 and 0, -4 and connect those 2 points with a line. So as we do that, we can maybe a little better see that, hey, this is in fact where it crosses the x-axis, and this is in fact where it crosses the y-axis. So what we did actually work. And what you need to remember as far as the math each time is if you find an x-intercept, you make y 0. Y-intercept, make x 0. AKA, you always make the other variable 0. So let's do the same with b and c. On b, we have 0 equals -x plus 12. You can either add x to both sides or subtract 12 to both sides. I don't really care which. So let's say we subtract 12. -12 equals -x. Divide both sides by -1, or multiply both sides by -1. X equals 12. So it's 12, 0. For the y-intercept, make x 0. -0 plus 12, well, it doesn't matter if 0 is negative or positive, that neither one actually happens. So 0 plus 12 is just 12. So it's 0, 12. Last but not least, letter C, 0 equals 1.2x plus 4.8. Subtract 4.8 from both sides and divide by 1.2. X would be -4. So you get -4, 0. And then the y-intercept. Y equals 1.2 times 0 plus 4.8. Well, anything times 0 is 0, and 0 plus a number is the other number. So y is 4.8, leaving us 0, 4.8. All right, so now we're actually finding slopes. So remember, we have this formula we're going to use. Time to use it. So for letter A, it doesn't matter whether I pick 5 or -4 first, which y value I pick first. Let's say I pick 5 first. Then I would subtract the -4. That means there's 2 negative signs in a row on the top there. We'll keep that in mind. On the bottom, because I chose 5 first, I have to choose 0 because they're part of the same ordered pair. Minus the -9. So 2 negative signs on the top and bottom means we'd be plus and plus them, change them to positive. 5 plus 4 is 9. 0 plus 9 is 9. 9 divided by 9 is 1. All right. So on letter B, same idea. M equals whichever one I want to pick. So I'm going to do -2 minus a -1 and 6 minus 1. So change those to positives. -2 plus 1 is -1. 6 minus 1 is 5. So I get -1/5. It doesn't matter if your negative's on the top or bottom of a fraction or out in front. The fraction's a negative. Letter C, let's say I do 3 minus -12. I like putting the smaller number, so if it's a bigger negative or just a smaller positive, second when I do these, if I can. So on the bottom, I'll do -7 minus -4 because I had to put the -7 first. since I chose to, put the 3 first on the top. So 3 plus 12 is 15. Negative 7 plus 4 is negative 3. So if I simplify 15 divided by negative 3, that's negative 5. And that completes the lesson for today.